Hello, good day everyone. Here is a very sweet exponential equation that you need to look for the value of x. But right now you can see that this is not a linear equation, nor is it a quadratic, nor polynomial, but it's an irregular exponential equation. Somebody just gave me this equation to solve for him one day ago, which is yesterday. And now I want to show you a technique or a method of solving this equation. You cannot just use an analytical method to solve this equation. But I will introduce to you the method that is called the Newton-Raphson method. This method is an iterative method that will give you the approximate value of x. Okay, then you can round off the value of x to get your result. This method starts like this. First step, you need to see the equation and rearrange the equation to suit an equation of root, to suit a function. Let's call it function of x. Yes, because of you have x as the variable. Okay, there's nothing to fear here. Then this one is just to collect like term. Here is x to the power of x, right? Then move this one to this side, is minus 2 to the power of x. Then move the 4, it will be minus 4. Okay, now we are working on this method like this now. So you have this. The next thing that you will do is to check the value of x. We want to do some checkings that will be equal to 0. If any value of x make this expression equal to 0, that is the answer. But in this case, there is no value of x that will make the result equal to 0. So what we will do now, that means there is no whole number, integer value of x that will make the result 0. What we do here is to try some things like at s equals 0. At s equals 0, that means this place will be 0, right? Here will be 0 to power 0, and 0 to power 0 is undefined. So we cannot choose x equals 0. Now let's take at x equals 1. At x equals 1. Then here will be 1 to the power of 1 minus 2 to the power of 1, then minus 4 is equal to 1 minus 2 minus 4. 1 minus 2 minus 4 is 1 minus 2 is minus 1. Here is minus 5. Then we check again function of 2 at x equals 2. At x equals 2, we have 2 to the power of 2 minus 2 to the power of 2, which is this, minus 4 is equal to 4 minus 4 minus 4, and which is equal to minus 4. You see now that minus 4 is closer to 0 than minus 5. So this one now is irrelevant. Then let's work more. Function of 3. All right, we are just trying at s equals 3. Okay, don't allow this function to deceive you. It means at s equals 3. At s equals 3, we have 3 to the power of 3 minus 2 to the power of s equal to 3 minus 4 is equal to, here is 27 minus, here is 8 minus 4. All right, 27 minus 8 is what? Is 19. Then 19 minus 4 is 15. Now you can see now that this one is minus 4, this one is plus 15. That is, there is a change of sign here. You start to work anytime there is a change of sign. It means that the root is between, the answer is between 2 and 3. Okay, because for you to shift from negative to positive, then you must reach 0 first. Okay, now let's do that now. X equals 2 or S equals 3. That means the root is in between S equals 2 and S equals 3. These are not the roots. Okay, these are not the roots. These are not the answer. Now, to get started with the Newton-Raphson method, at first, here is the function. We need to differentiate it once. You need to differentiate it once. That means you need to have the knowledge of calculus. Here is the function. So we have, for us to differentiate it once, it will look complex. So let's take it step by step. Let's differentiate this one first. That is, let y equals x to the power of x. All right, let's differentiate this one first. To do that, here is x to the power of x, so you add ln to both sides. Add ln to both sides. Here we have ln x, or take ln to both sides, yes. Ln y is equal to, here is ln x to power x. Then ln y is equal to, since this ln is natural logarithm, we need to take this x to the other side, which is x ln x. Here is a product rule. So to differentiate that first, let's differentiate ln y. To do that, ln y is 1 over y. And anytime you are differentiating y, you add dy all over dx, right? Here is a product rule. So the simple step is to take this one first, x, times differentiate the other one, which is 1 over x, plus, next, you take this one first, ln x, times differentiate the first one, 1. And this one now, you believe me, x will cancel x, then here will be 1, plus ln x times 1 is ln x. So dy all over dx is equal to, move this y to the other side, you will have y into 1 plus ln x. And what is y? Y is x to power x, which is this. X to power x into 1 plus ln x. Here is the first one. Then we'll go ahead and differentiate this other one, 2 to the power of x. Do the same thing. Let y equals 2 to the power of x. Then ln y is equal to ln 2 to the power of x, and is equal to x ln 2. Then you differentiate both sides again with respect to x. Here will be 1 all over y, dy over dx is equal to, here is also a product rule. Here is not a product rule. This ln 2 is a constant. So let's differentiate x is what? Is 1. So you are left with ln 2. Then dy all over dx is equal to y ln 2, and is equal to, what is y? Y is 2 to the power of x and ln 2. So we are done with the derivative, okay? we are done with the derivative. Because if you differentiate minus 4 is 0, so we have nothing to do with that. Let's apply it now to Newton-Raphson method. Let's apply it to Newton-Raphson method. I want to give you the formula for Newton-Raphson method. Now, here is the formula. Xn plus 1 is equal to xn minus function of xn all over f prime of xn. This formula should not confuse you, all right? This xn plus 1, it means the next root. It's an iteration. It means the next root. Then this xn is the current root. You see now that they are all the same here. This f prime of x is the differentiation that we made. Just remember, f of x is equal to x to the power of x minus 2 to the power of x minus 4. Okay? Then f prime of x is the derivative that we made. All right, which is differentiate this first one is what? Is this x to the power of x into 1 plus ln x. Then minus the other one, differentiate this one, is 2 to the power of s ln 2. Here minus 4 is out. And this one here is equal to s to the power of x. Okay? Okay. All right, which is this. So now, what are we doing now? What we do now is to bring out the root. The root that we had at first, which is this. These two. We need to check which one is closer to 0. Which one is closer to 0? You will see that this minus 4 is closer to 0 than 15. Yes. So that means the first root will be 2. Okay, will be at s equal to 2. At s equals 2, then we call it s naught. S naught. So if we call it s naught, then here will be x 1, 0 plus 1, which is 1, is equal to, here is s naught minus f of x naught all over f prime of x naught, which is equal to x naught is 2 minus f of 2 all over, 2 minus f of 2, the over is just here, f prime of 2. That means we need to get f of 2, of which we have already here as minus 4. Then we also need to have f prime of 2, okay, which is all this. So at s equals to 2, we just place it here like this. So we have equal to 2 minus, here is minus 4, okay, all over f prime of 2, then here will be 2 raised to the power of 2, right? 2 to the power of 2, because here is 2 to the power of 2, into 1 plus ln 2 minus 2 to the power of 2 into what? Ln 2, okay? Now here you will see that is equal to 2 minus 4 into, here is 4, 1 plus ln 2 minus 4 ln 2. and is equal to 2, yeah, minus, okay, let's still leave it like that. Here is minus 4. 4 and 4 is common, pick one. Then here will be 1 plus ln 2 minus ln 2. 2 minus 4 into ln 2 minus ln 2 is out. So these two will die off. 1. 2 minus minus 1 is 3. So we can see now that x1 is 3 and s0 is 2. But when we plug in the 3 here, we got 15. That means 3 is not the answer, 2 is not the answer. The answer is in between 2 and 3. So we check another value in between 2 and 3. Okay, now let's go with 2.5, which is the middle. 2.5. Take note, the reason why we choose 2.5 is because the answer is in between 2 and 3. That means we find 0 between 2 and 3. So, and the middle of 2 and 3 is 2.5. Let's check. 2.5 into 2.5, here will be 2.5, 2.5 minus 2 to the power of 2.5, then minus 4. Let's go straight to the calculator. I have the calculator in my phone. 2 point, shit, 2.5 to the power of 2.5 minus 2 to the power of 2.5 minus 4 is equal to 2.2, sorry, 0.2225. 0.225. Now you see now that this one is very close to 0, but it's positive. That means we can start working with this, or we can look for another value that is negative and also close to 0, so that we select which one we will use. Check 2.4. 2.4 function of 2.4 is equal to 2.4 square, sorry, 2.4 to 2.4 minus 2 to the power of 2.4 minus 4 is equal to minus 1.103. Here we see that this one is closer to 0 than this. So we choose this as the root. Or sorry, we choose this as our new value of x in our iteration. So now here is s1, or sorry, okay, let's just use s0, our new s0 is equal to 2.5. We will still do the same thing here. So x1 will be 2.5 minus what? Function of 2.5 all over f prime of 2.5, and is equal to 2.5 minus function of 2.5 is 0.225. Still remember that the answer is in between 2.5, yes, it's in between 2.5 and 2.4. Good. Now, f prime of 2.5, go back to our f prime of x. So, which is 2.5 to the power of 2.5 into 1 plus ln 2.5 minus 2 to the power of 2.5 ln 2. All right, now let's still press our calculator. Here we have 2.5 minus 0.225 all over, let's go straight, 2.5 to the power of 2.5 into 1 plus ln 2.5 minus 2 to the power of 2.5 into ln ln 2. The answer here is 15.016. All right, now we have this. So let's continue to subtract. Let me just go straight ahead to subtract. Or 2.5 minus 0.0225 divided by 15.016, 0.0015, and is equal to 2.5 minus 0.0015, 2.4985. So you see now that this result is in between 2.4 and 2.5. So you can continue your iteration by picking this one now. And by picking this one now, like x2 is equal to 2.4985 minus function of 2.4985 all over f prime of 2.4985. Then you still do the same thing that you did here. All right, let's do it. Is equal to 2.4985 minus, let's put the function here now, 2.4985 all to the power of 2.4985 minus 4, minus 2 into 2.4985 minus 4 all over, take note here is inside the bracket, all over f prime is what? Is this. So 2.4985 to the power of itself. 2.4985 to the power of 2.4985 into 1 plus ln 2.4985 minus 2 into 2.4985 ln 2. Yeah, now you can solve this one and get your answer. So you can end here, you can end at this answer when you press your calculator. So the value you have here is very close to the answer. Since it's very close to the answer, you can approximate the answer as the final answer. Or you can even stop here at s equals 2.4985. So the more you continue the iteration, the more accurate your answer for s is. All right. Thank you very much for watching. Please do subscribe for more tutorials like this. If you have questions on utilizing method, you can do well and ask. Or if you want more class on this, to start you from the grassroots so that you will understand it more instead of starting from complex problem like this. Then I will start with you from the elementary stage so that you will understand this approach of solving nonlinear equations very well. Bye. Do have a lovely day.